Hey there, awesome physics students. Let's talk about how to get the position time graph if you already know the velocity time graph. So here I have an example of velocity time graph where the velocity starts at positive 10 meters per second for 2 seconds. The velocity is 0 for 1 second, and then the velocity goes down to negative 5 meters per second for 2 more seconds. So given this, how do we get this? Now remember our sort of mantra that we want to remind ourselves when we're working with these graphs. That is, the value in one place is going to be this slope in the other place. In this case, the value of the velocity time graph is the slope of the position time graph. So let's start with the value here is a positive 10 meters per second. It's constant. So the slope here needs to be a positive 10 meters per second slope, a constant slope. So a constant positive slope looks like that. So let's go ahead and we'll just start here at the origin, and we'll draw it up like that for 2 seconds. And then again, the value here is the slope here. So the value here is 0. That means the slope here should be 0. And you see how I'm repeating this. This is what you need to do when you're doing these graphs. Repeat the value here is the slope here. Otherwise, it's very easy to get confused. Value here is 0, so slope here needs to be 0. A 0 slope is flat. So I'm going to draw a flat line for 1 second. So this is 3 seconds total. And then the value here is negative 5. So the value here is the slope here. Value here is negative 5 meters per second. That means the slope here needs to be a negative 5 meters per second slope. A negative slope is a curve downwards like that. It's a constant value, so this needs to be a constant slope. So that's a straight line. Okay, so I'll go out like that for a total of 5 seconds. And so then the question you might ask yourself is, okay, how do we know, now that we've got the shape correct, and as always, I always encourage you strongly to get the shape correct first and then fill in the values at the end. So how do we get the values here? Well, we know that we could get this backwards from the slope, but let's do it a slightly different way. That is that if we take the velocity time graph, the velocity is equal to the displacement over the time interval. If we rearrange this, we can rearrange this to get the displacement is a product of the velocity times the time interval. And what this tells us, suggests to us, is that we need to multiply the velocity in the time interval. Now, in this particular case, the velocity is constant, but in general, the velocity is not going to be constant, but this also suggests a process by which you should do that, and that is the area underneath this curve is going to be the displacement. Okay, so let's find the area underneath this curve. This is shape is a rectangle, so the height is positive 10 meters per second. And I'm going to multiply that by the width here, which is 2 seconds. And so I get 10 times 2, which is trivial, it's 20. But notice why I did this out in detail is because I wanted to show you that the meters per second here times the seconds here, the seconds cancels the seconds here, and I'm left over with 20 meters. Okay, so even this process can help us check ourselves to make sure that we know that we're doing it the right way. So this says the area here is a positive area. It's a positive 20. That means I need to increase my position by 20. So this, since I started at 0, I will go up to 20 meters here. Okay. Then when I'm at 0 velocity, of course, there's no area here. I stay at 20 meters. And then to get the height here, I need to find the area here. And the area here is going to be, well, the height here is a negative 5. So this is going to be negative area, negative 5 meters per second. And I multiply that by the time interval. Now, would I multiply by 5 or 3 or what? Well, I want the time interval. So that is the differences in the two times here. This is a length of 2 seconds. So I'm multiplying by 2 seconds again here, right? So I'm multiplying by that time interval. So negative 5 times 2 is negative 10, and the units again will cancel. Seconds will cancel with seconds here, and I'm left with meters. And so this means I need to change my position by negative 10. So that means I need to go from here where I was at the beginning of the motion and decrease by 10. So that takes me down 20 minus 10 is a positive 10. Okay. All right. So keep in mind this is telling me the displacement, that is the change in position. That tells me how much to move up or down on this position time graph. It doesn't tell me the absolute position. I have to begin where I have to know where I'm starting first and then move either positive 20 or negative 10 from that. Okay. Now, one more point that I didn't discuss here, and that is I assumed to start at 0. There's no way from this velocity time graph for me to know that I have to start at 0. Someone has to tell you that. So now I assumed that for this problem, but I wanted to bring this up at the end, is that the problem needs to tell you whenever you're given a contrived problem like this one is, you need to say, give it a starting point. X equals 0 meters at t equals 0 seconds. So someone needs to tell you that. Or you need to be told, okay, you start here, and then how far away from the origin or wherever. Okay? So this is how you get a position time graph from a velocity time graph. All right?